class, it's Mrs. Pemberton, and this is homework help with page 67 and 68 out of your practice book. So the first question, can you represent either of the functions above in table A or B with an equation? So as you read through these examples and you're looking from input to output, you're looking for a rule each time that would work. And as you look through these, moving from input to output, on table A, you're multiplying by 3 each time. So you would write yes, table A, because you can represent it with y, or your output, is 3 times your input, or x. Remember, input is x, output is y. As you move to table B and you're looking from input to output here, there's not a nice, neat multiplication or division you can do here to go from input to output. So table B would not work with an equation. As you go to number 2, it says suppose you reverse the inputs and outputs here. So now, instead of these inputs being on top, they're going to be down below here. So I'm going to switch them just so we can visually see our outputs. Let's see, 2, and then 1.75. And then that would match with what was your input. So we're just switching these. That's what the problem's asking, if it's still a function after you switch them. And as you look at the example vocab down below, a function, remember, has each input only has one output. Look at these inputs, though. You have 2 x values, or 2 inputs, that are both 2. And they're giving you 2 different outputs. So this is no, not a function. So that would not be a function here. We'd write no, and we would explain that the input 2 has 2 different outputs. I'm going to abbreviate here, 2 different outputs. Okay, on number 3. So the table shows the number of concert tickets sold by 5 students. Is the relationship a function? Explain. So here's your 5 students, 5 different inputs, and how much they sold, how many concert tickets they sold. So as you're looking here, you notice that you have all different x values, or all different students. So yes, this would represent a function. And there's a couple ways you could say it. You could say each input has one output. You could also say each x has only one y, or that you have all different inputs here. Okay, I'm going to go ahead and switch to the next page. And let's see here, let's scroll. And we're just going to do number 4, 5, and 6 on the next page here. Okay, so the table shows the number of calories in different numbers of servings of blueberries. So when you eat 1 serving of blueberries, that's 21 calories. 2 servings would be 42. Okay, and so on. On the blank graph to the right, add the title, and then label the number of axes. So we're going to go ahead and do that. And we practiced that a little bit today. So we'll title it blueberries. And then we'd have servings. That's our input. And our output would be calories over here, and I'll abbreviate calories. And then we're going to go ahead and number our axes. So 0, and you can keep going there. And then we'll number, and I'm going to go by 15s here. And you can keep going from there. And then we'll go ahead and graph those, okay? So we're going to plot the ordered pairs on the graph. So for 1 serving, let's actually start with 0. If I don't eat any blueberries, it's 0 calories. 1 serving would give me 21, so I'll kind of estimate there a little bit. 2 servings would give me 42, right beneath that 45 line. 3 servings will give me 63. 4 servings will give me 84. So again, just plotting these points. And 5 servings would give me 105, which is this line right here. Cool. Now it says explain whether the relationship is a function. Yes, it is a function. So as we look, each serving of blueberries has a different output. So each input or serving of blueberries has one output. It wouldn't make sense if we had one serving of blueberries be 21 calories and one serving of blueberries is also 45 calories. That wouldn't make sense. The next part of this, can you represent the data with an equation? If so, write the equation. Okay. So as you look at this, each time you're multiplying by 21 calories. So we would say that the calories, or your output, is 21 times the number of servings, the input. Last question. Substitute values into the equation for y equals x minus 3 to complete the table. We did this last week with a versatile, so we're going to go ahead and plug in our x values. So like for the first one, I'd replace x with negative 2, minus 3 more gets you negative 5. We keep going. Now I plug in negative 1 minus 3. That gives me negative 4. Plug in 0 minus 3. Plug in 1 minus 3. And last but not least, plug in 2. Okay. The next part. So state whether the equation represents a function. Explain your reasoning. Okay. So as you look, you have all different inputs, and they all have exactly one output. So we would say, yes, this is a function. Each input has one output. Okay, hope this helps. See you guys tomorrow.